Welcome to Pristine Maths Club. Like, comment, subscribe. Look at Locus 3. The locus of points equidistant from two intersecting lines is a pair of bisectors that bisect the angles formed by the two lines. Okay? Well, let us now look at, we have a line AB. We also have a line CD. Okay? The line A, B, and CD meet at point 0. So we want to bisect angle BOD. Okay. To bisect angle BOD, we have the arc. The way we have that arc, then we put it into that point. We have the arc also up there. We have the second arc there. So where the two arc means, we join it with point O. Okay, so that's the locus. We have divided the BOD into two equal parts. We do it for BOC as well. Okay, we do the same thing. We bisect the BOC, angle BOC. Okay, we also join that to the point 0. So we have we can see that the same thing divide AOD from BOC. That line divide AOD. The same thing BOD is also divide AOC. Those two lines, they are the loci. They are the loci for the two lines that intersect. So we have the loci for that. Let us look at example. Example now is that two lines PQ and ST. When you see two lines, when they intersect, you should know that is the bisection of the angle between two of them. That would be the locus. The line PQ and ST intersect now and make an angle of 75 degree. So then we have to bisect the angle 75 degree into two. So we have the bisector of the angle between line P or PQ and ST. So definitely the answer should be option A. Let's look at another example. We want to determine the locus of a point inside a square PQRS, which is equidistant from PQ and QR. We have a square now, PQRS. Okay, and since we are to get the locus between angle PQ and QR, meaning that we have to divide the angle between the PQ and the QR. So in this case, we should know that the Q there, we are going to divide the angle. And so you have just a straight line that will cut the angle from Q to S, and that is the diagonal QS. So we'll say that the diagonal QS is the answer, and that is the option B. Locus 4. The locus of points equidistant from two parallel lines is a line parallel to both lines and midway between them. Let's look at it here. We have a line AB. We also have another line CD. Both line AB and line CD. Let's have a line CD there. Both line AB and line CD, they are parallel. They are both parallel. The locus will be in the midway between a line AB and CD. So we have the locus between both of them in the midway. So that is how to get the locus between two parallel lines. It will be in the midway between them. The same distance of the locus to AB, the same distance also to CD. Okay, let us look at example on this. Find the locus of point equidistant from two straight lines. Straight line y minus 5 equals to 0 and y minus 3 is equals to 0. So what's the first line? Y minus 5 is equals to 0. It means y is equals to 5. And the second one is also y minus 3 is equals to 0. It means y is equals to 3. The one that is y is equals to 5 You can see it on the Cartesian now. A line y is equals to 5 is that. And the same thing, y minus 3 also is equals to 0. It means y is equals to 3 as well. Okay, let us also put that horizontal line in our Cartesian. You can see that the midpoint between the two will be the 4. That will be the locus for the two parallel lines in that way. So our answer will be y is equals to 4, which means y minus 4 is equals to 0. Option B. Okay, locus 5. Locus of points equidistant from a straight line is a pair of parallel lines of the same distance to the straight lines. Okay, let's look at AB now. A line AB. I want to get the locus that will be to this line AB. Let's take for example. Let us have a locus that will be 2 centimeter from line AB. It can be 2 centimeter downwards. It can also be 2 centimeter upwards. So we can now see the locus now. The one that is upward and the one that is downward, both of them will be parallel to this and must be of the same distance to line AB. Let us look at example now. Okay, find the locus of a point which moves such that its distance from the line y is equals to 4 is a constant. Okay, to be able to do this, I think we should be able to have a Cartesian plane. Let's have a line that is y is equals to 4 on the y-axis. Okay, and you can see the locus that will be a pair of line upwards and at the same time downward. So, and the two lines must be parallel as well. Okay, suppose we say that let the k equals to 1, meaning that the first locus will be at 5 up there. So we have 4 plus k. That's 4 plus 1, 5. We can also say the one downward also, let it also be 1 to our main line, which is 4. So that means that it will also be what? 4 minus 1, which is 3. And since we said that let's our k is equals to 1, so those are the two locus, 4 plus k and 4 minus k. So the locus now will be 4 plus or minus k, and that will be our option D. Another example, the locus of the points which is equidistant from the line PQ forms of course a pair of parallel lines to PQ. If it's a locus to a line, it usually form a parallel line to the line, and the parallel line will be the one downward and upward. So option C is the answer. Okay, another example. What is the locus of points equidistant from the line AX plus BY plus C is equals to 0? Oh, we are giving the line, the same line. Of course, the line that will be of the locus to this a line must be parallel to that line. And in this case, we have to make use of what is called the equation of a line. For two lines to be parallel, the gradient slope or slope must be the same thing. So when two lines are parallel, the slope must be the same. The slope of the first one, let's say m1, will be equals to the slope of the second line, which is also m2. So we should recall the formula for equation of a straight line. Y is equals to mx plus c, where the m is the gradient. So in this case now we take our ax plus by minus c equals to 0. We'll be able to get the gradients by making y the subject of the formula. Okay, here in this case, when we make y the subject of the formula, you can see what we will get now. Or we'll get y is equals to minus ax over b minus c over b. So in this case, our gradient now, if we compare this with what we have as the general equation of the motion of the straight line. So in this case, the m, by comparing them, we will know that the m is equals to minus a over b. That is the coefficient of x. Or the c there is equals to the y-intercept. So it won't be the same thing. So if you look at all our options, the one that will have the coefficient, that will have the gradient or slope to be equals to minus a over b, or is the, I think should be the option A. Let us look at further problem. Example, P is on the locus of a point equidistant from the given point x and y. UV is a straight line through y parallel to the locus. If angle PYU is 40 degrees, find angle XPY. Okay? To do this, let's try to make a sketch so that we can understand it better. We have a horizontal line XY, our straight line. And we know that the locus from two fixed point is the perpendicular bisector of the two lines. So we have the bisector. In that case, we can see the vertical line there is the perpendicular bisector. The question says that P is on the locus, and let us put P there. And it's also said that the UV is a straight line through Y parallel to the locus. So we have the UV now, which pass through Y and is parallel to the locus. And we have been given PYU to be equals to 40 degree in the question. Since we have two vertical lines that are parallel, so we should have the alternate angle. That is, this place also equals to 40 degree. Okay. We should also know that Py is also equals to Px, according to what we have done in the past. Any letter on the locus must be equal, have an equal distance from the fixed point x and y. So Px is equals to Py. That's an isosceles triangle. So in that case, we also have a 40 degree over there. So we can now see that XPY now is equals to the 40 degree, and with XPY equals to the 240 degree. We add them together, give you 80 degree, which is option B. Okay, example. The locus of all points at a distance 8 cm from a point N passes through point T and S. If S is equidistant from T and N, find the area of triangle STN. Okay, when they say locus from a point, we should know that it's a circle from our previous lecture. So this is a circle. In this case, we have to draw our circle of radius 8 centimeter. Remember that we're told that the S and T, they are on the locus, meaning that they are on the circumference of the circle. So we put our S and T there. We have also been told that S is equidistant from T and N, meaning that Sn is also equals to St. So we have the equilateral triangle of STN, meaning that all the sides, they are equals to 8 centimeter. To solve this, we will use the formula for area of a triangle is equals to half r square sine theta. So half times the r square now, a radius equals to 8, and sine theta is equals to, theta is 60 degree because this is an equilateral triangle, and in an equilateral triangle we should know that all the angles there is equals to 60 degree. So in this case, that's why we are using the 60 degree in as the angle there. Okay, solving this, sine 60 degree is a special angle, is square root 3 over 2 times 8 times 864 times 1 over 2. So by the time we solve this, we arrive at the answer 16 root 3. Option B. Do not forget to subscribe to my channel, like and comment. Thanks.